Welcome to Science, to sleep by. As you lie back tonight, closing your eyes and letting the day slowly fade away, I invite you to drift into a story that belongs to all of us. A story not of tomorrow, but of countless yesterdays. What if the earth we know, the mountains, the oceans, the civilizations, was not the first version of our world? What if Earth itself has been reset, time and time again, like a great cosmic clock starting over? Tonight, let us explore the hidden past of our planet, the forgotten worlds beneath our feet, and the possibility that Earth has been renewed more times than we can ever imagine. When we speak about the idea of Earth being reset, we are not talking about a button being pressed or a single moment of change, but rather about a process that has repeated throughout the deep history of our planet. Earth has never been a static world. It is a living, evolving system in constant transformation, shaped by geological upheavals, astronomical encounters, biological revolutions, and climatic extremes. To say that Earth has been reset is to acknowledge that there have been moments in time when the trajectory of the planet, and of life itself, has been drastically altered, sometimes so completely that the world that followed bore little resemblance to the one that came before. This is not the realm of fantasy, but of science, because the geological record, the fossil archives, and the study of cosmic influences all suggest that Earth has experienced many cycles of destruction and rebirth. Think of the Earth's surface as a palimpsest, a manuscript that has been written over again and again. Beneath the soil we walk on today lie countless earlier versions of the world, some buried, some erased, some hidden in fossilized fragments. To understand planetary resets, we must first appreciate that Earth is 4.5 billion years old. In human terms, that is a span so vast that our minds struggle to comprehend it. If we compressed Earth's history into a single calendar year, with January 1st marking the birth of the planet and December 31st marking today, then humans as we know them would not appear until the very last minutes before midnight on the final day. Everything we consider history, from ancient Egypt to the modern United States, would be a mere blink in this scale. Yet within this immense span of time, Earth has seen countless changes that were so profound, they could rightly be called resets. And of the clearest ways to think about planetary resets is through the lens of mass extinction events. These are not minor disruptions, but moments when most of the life on Earth vanished, clearing the slate for entirely new forms of life to emerge. The Permian-Triassic extinction, which occurred about 252 million years ago, wiped out nearly 90% of all species. Imagine standing on Earth in the aftermath of such an event. Forests gone, oceans nearly sterile, creatures that once dominated the land and sea erased in a geological instant. The survivors, often small and overlooked, became the ancestors of the next great wave of life. Without that reset, the dinosaurs might never have risen to power, and without the eventual extinction of the dinosaurs, mammals like us might never have had our chance. This is the pattern: destruction followed by renewal, collapse followed by reinvention. But planetary resets are not always sudden cataclysms. Sometimes they are slow, almost imperceptible, yet no less transformative. Consider the cycle of ice ages. For the past 2.5 million years, Earth has slipped in and out of glacial periods, when vast ice sheets spread over continents, carving valleys, reshaping coastlines, and forcing life to adapt. During these times, sea levels dropped dramatically, climates shifted, and ecosystems were restructured. Humanity itself was shaped by these resets. Our ancestors learned to survive in harsh, fluctuating environments, and the migrations that defined our species were often driven by the ebb and flow of ice. Each return of warmth brought new opportunities. Each freeze pressed living beings into patterns of adaptation and resilience. Though slower than an asteroid strike, an ice age is still a reset, one that redraws the map of Earth again and again. Even before life emerged, the planet itself experienced resets at a geological scale. In its earliest billion years, Earth endured massive impacts from space. Some scientists believe that the Moon itself was born from such a colossal collision, when a Mars-sized body slammed into the young Earth, scattering debris that eventually coalesced into our companion in the sky. Later, Earth went through a period called the Late Heavy Bombardment, when asteroids rained down so frequently that oceans may have boiled and life, if it had begun, was constantly pushed back to its earliest forms. These were resets not just of life, but of the very conditions that made life possible. Without them, Earth might look more like Mars or Venus today, lifeless, barren, or hostile to complex organisms. A third dimension of resets comes from Earth's internal dynamics. The shifting of tectonic plates constantly remakes the surface of the world. Continents drift, collide, and break apart, raising mountains and creating new seas. What we call stable land today was once ocean floor, and what lies beneath our feet now may one day vanish beneath waves or be thrust up into towering peaks. The supercontinents of the past, like Pangaea, are long gone, shattered into the continents we know today. In the far future, new supercontinents will form again, and the face of the planet will reset once more. These slow dances of rock and magma, driven by the heat of Earth's core, ensure that the planet is always in flux. Even without life, Earth would still reinvent itself. When we look at these processes: asteroid strikes, extinctions, ice ages, continental shifts, we begin to see a pattern. The story of Earth is not linear, but cyclical. The idea of a reset is not just poetic language, but a reflection of reality. Each age ends, each age begins anew. This is why some scientists and thinkers suggest that Earth itself is resilient, that even in the face of devastation, the planet finds ways to heal and start over. For us, as humans, a planetary reset feels like the ultimate catastrophe, but in the broader scale of time, it is part of the natural rhythm of existence. What is lost makes way for what is yet to come. In our own time, we may wonder if humanity is approaching its own reset. Climate change, biodiversity loss, nuclear risk, and technological disruption all pose questions about whether we are pushing our world toward another transformation. Yet it is important to remember that Earth has endured for worse and still continued. The question is not whether Earth will reset, but what role we will play in that story. Will we adapt, like the survivors of past extinctions, or will we be among the species that vanish, leaving room for new forms of life to thrive? To reflect on planetary resets is not only to look back at history, but also to gaze into the future, to imagine what the next chapter of Earth's great cycle might hold. To truly grasp the idea that Earth may have already been reset, we must step into the vast expanse of what scientists call deep time. Deep time is the incomprehensible stretch of billions of years that represents our planet's history. It is a timeline so immense that the entire span of human existence seems like the faintest whisper against its background. We often measure history in centuries, sometimes in millennia, but deep time stretches into spans so enormous that numbers lose their meaning. To reflect on it is to understand that the Earth we know today is only one fleeting version among countless others, many of which have vanished so thoroughly that only fragments of their existence remain. Imagine compressing the entire 4.5 billion years of Earth's history into a single year-long calendar. In this analogy, Earth forms on January 1st. Life does not appear until around March, and even then it is only the simplest microscopic organisms. Complex, multicellular life does not emerge until November. Dinosaurs do not arrive until December 13th, and they are gone by December 26th. Modern humans only appear in the final minutes of December 31st, and all of recorded history occupies the last seconds before midnight. This way of seeing things emphasizes not only how short our own story has been, but also how much of Earth's story has been forgotten, buried under the weight of time, erased by geology, or hidden by the cycles of resets. Most of what has happened on Earth is invisible to us. The continents have shifted, mountains have risen and eroded away, oceans have opened and closed, climates have swung between extremes of ice and heat. Civilizations like ours, if they ever existed in the distant past, might have been wiped away without leaving a trace, their remnants swallowed by oceans, ground into dust by glaciers, or subducted deep into Earth's mantle by the slow churn of tectonic plates. What remains of Earth's earliest history is fragmentary, like scraps of paper floating in an endless void, leaving us to reconstruct a narrative that will always be incomplete. This is the forgotten Earth, the version of the planet that existed before the one we now. Scientists searching for clues about these lost chapters often turn to rocks, minerals, and fossils. Yet even these are imperfect witnesses. Rocks are recycled over time. The ocean floor itself is renewed every 200 million years, meaning that no part of the seafloor is older than that. If anything had been built or buried there long ago, it would now be gone, swallowed back into the interior of the planet. Fossils, too, are rare, for the conditions required for preservation are extraordinarily specific. Most living things vanish without a trace, decomposed and scattered, leaving behind no sign of their existence. What we call the fossil record is a narrow window, showing us only a fraction of the creatures and plants that once thrived. If Earth has already been reset, much of that evidence is lost to us forever. Deep time also reshapes our perspective on human civilization. The structures we build today, our cities, our monuments, our machines, feel permanent to us, but in geological terms, they are temporary. Given enough time, everything we have made will disappear. Steel rusts, concrete crumbles, glass weathers into grains, plastics eventually break apart, and even nuclear waste will decay into harmlessness over hundreds of thousands of years. If humanity were to vanish tomorrow, within a few tens of thousands of years, there would be little left to mark our presence. Forests would reclaim cities, seas would rise and drown coastlines, tectonic forces would rearrange the land. In a few million years, any trace of us could be gone, just as the traces of countless forgotten ages before us have vanished. This is why, when we contemplate Earth's deep time, it is entirely possible that resets have occurred before, wiping away worlds and stories we will never recover. Consider the earliest life forms. Microbes dominated Earth for billions of years, and in many ways, they still do. Yet for most of that time, the planet looked nothing like it does today. The atmosphere was once devoid of oxygen, a toxic sky for creatures like us. It was only through the slow work of photosynthetic organisms that oxygen accumulated, leading to what scientists call the Great Oxidation Event around 2.4 billion years ago. This was one of the earliest planetary resets, because it radically altered the environment, wiping out organisms that could not tolerate oxygen while opening the door to new kinds of life. From the perspective of deep time, this moment is as profound as the extinction of the dinosaurs or the rise of mammals. It reminds us that resets can occur at scales we barely understand, shaping not only life, but the very chemistry of the air we breathe. The forgotten Earth is also full of mysteries. There are vast stretches of time for which we have almost no record at all, sometimes referred to as lost eons. The Hadean Eon, for example, covers the first half-billion years of Earth's existence, a time when the planet was bombarded by asteroids, its surface molten and unstable, its oceans forming and evaporating in violent cycles. We know almost nothing of this world, and yet it was the stage upon which life itself may have begun. Later eons, like the Archean and Proterozoic, contain their own puzzles, traces of continents forming, microbial mats leaving behind faint patterns in stone, strange chemical signatures suggesting climatic extremes like snowball Earth, when ice may have covered the globe from pole to pole. These eras are alien to us, belonging to versions of Earth so radically different from today's that they are almost unrecognizable. They are chapters in the book of Forgotten Earth, overwritten by the resets that follow. Time humbles us. It shows us that our species is not the center of history, but a recent arrival in a long sequence of transformations. It invites us to imagine that other stories, other experiments in life, may have risen and fallen long before us. The trilobites that once scuttled across ancient seafloors ruled their ecosystems for hundreds of millions of years, longer than mammals have existed. Yet they too were swept away in an extinction event, leaving only fossils as their legacy. Dinosaurs thrived for 165 million years, far longer than humanity has walked the Earth, yet their reign ended suddenly when a space rock struck the Yucatan Peninsula. These stories remind us that dominance does not guarantee permanence, and that in the context of deep time, resets are the rule rather than the exception. In the United States, where landscapes vary from the ancient rocks of the Grand Canyon to the shifting sands of coastal plains, we can see glimpses of deep time in our own backyard. The layered cliffs of Arizona tell a story of oceans that once covered the land, of deserts that once spread across vast regions, of climates that came and went over hundreds of millions of years. The Appalachians, worn down to rolling hills, were once towering mountains rivaling the Himalayas, raised up when continents collided in a world that no longer exists. Yellowstone, with its geysers and hot springs, whispers of the immense forces still shaping the earth from within. All of these places are reminders that the world we inhabit today is only the latest page in a book that stretches back beyond memory. When we close our eyes and think about deep time, we are stepping into the forgotten earth, a place of vanished oceans, lost skies, and creatures that no longer walk the land. It is a perspective that calms us, because it reminds us that change is natural, that endings are followed by beginnings, and that what feels permanent is always temporary. It also sparks wonder, because it invites us to imagine what has been lost, and what may come again. To see ourselves as part of a much larger story that has unfolded for billions of years, and will continue long after we are gone. When we think about the idea of Earth resetting, few events in history illustrate it more vividly than the great mass extinctions. These are moments when life as it existed was almost entirely erased, when ecosystems collapsed, when dominant creatures vanished, and when the evolutionary path of the planet was redirected toward an entirely new future. Unlike smaller, local extinctions that might affect a single species or region, mass extinctions are planetary events. They sweep across continents, oceans, and climates, leaving almost no corner of Earth untouched. They are, in many ways, the clearest examples of Earth wiping its own slate clean and beginning again with whatever survivors remained. Science recognizes 5 great mass extinctions in Earth's history, though some argue there may be more. Each of these moments changed the face of life so completely that they serve as natural dividing lines in the fossil record. The first, known as the Ordovician-Silurian extinction, took place about 443 million years ago. It was triggered, scientists believe, by a sudden global cooling as massive glaciers formed, lowering sea levels dramatically. Most life at that time lived in the oceans, and with the loss of shallow marine environments, nearly 85% of species were wiped out. Coral reefs collapsed, and creatures that had thrived for millions of years disappeared. Yet this catastrophe cleared the way for new organisms to diversify in the Silurian period that followed. It was the first major reset that reshaped the evolutionary course of Earth's second great extinction. The late Devonian event happened around 359 million years ago. This one was more prolonged, stretching over millions of years. It devastated marine life once again, particularly reef-building organisms. The causes remain debated, perhaps massive volcanic eruptions, perhaps changes in ocean chemistry, perhaps a drop in oxygen levels. Whatever the reason, the world was transformed. Entire ecosystems vanished, and yet, in the aftermath, new forms of plants and land animals began to rise. Forests spread, reshaping the air itself with increased oxygen, and paving the way for the amphibians and reptiles that would come to dominate. This, too, was a reset, one that ended an age and began another. The third mass extinction, and by far the most devastating, occurred about 252 million years ago. It is known as the Permian-Triassic extinction, or sometimes simply, the Great Dying. This event eliminated more than 90% of species, both on land and in the seas. It was the closest life on Earth has ever come to total annihilation. Imagine a planet where forests burned, oceans turned toxic, and skies darkened with volcanic gases. Siberian traps volcanism, a cataclysmic outpouring of lava that lasted for hundreds of thousands of years, is believed to have triggered massive climate shifts. Methane released from the seafloor may have supercharged global warming. Acid rain poisoned the land, and the chemistry of the oceans changed so drastically that marine creatures suffocated. Out of this devastation, ecosystems collapsed entirely. Yet, astonishing, life survived. A few resilient species held on, and from them, entirely new lineages emerged. This reset marked the dawn of the Triassic period, which in time gave rise to the age of dinosaurs. Without the Great Dying, the reptilian giants that once ruled the Earth might never have appeared. The fourth extinction came about 201 million years ago, at the end of the Triassic. It wiped out many of the reptiles that had risen to prominence, opening the way for dinosaurs to take over. Once again, the suspected culprits were massive volcanic eruptions, climate shifts, and changes in ocean chemistry. This extinction, though not as total as the one before, was still a profound reset. It cleared ecosystems of competitors, leaving ecological space for the dinosaurs to expand into, dominating both land and sky for the next 135 million years. This period of dominance would shape Earth's history for more than 100 million years, until yet another reset brought their reign to an end. The fifth and most famous extinction is the one that ended the age of dinosaurs 66 million years ago, at the boundary between the Cretaceous and Paleogene periods. This is the event most people think of when they hear mass extinction. A 6-mile-wide asteroid slammed into the Yucatan Peninsula in what is now Mexico, releasing energy equivalent to billions of nuclear bombs. The impact created a crater more than 100 miles wide, hurled debris into the atmosphere, and set off wildfires around the world. Dust and ash blocked sunlight, plunging the planet into a period of cold and darkness. Photosynthesis collapsed, food chains unraveled, and the mighty dinosaurs, along with countless other species, perished. Yet once again, life found a way. The small, the adaptable, and the overlooked survived, among them early mammals. With the dinosaurs gone, mammals diversified into forms that would eventually include primates, and ultimately, humans. In a very real sense, our existence is a direct consequence of that extinction. Reset. Without the asteroid impact, dinosaurs might still rule the Earth, and we would not be here to wonder about it. These 5 events are only the most dramatic resets, but they illustrate a pattern that runs throughout Earth's history. Life rises, flourishes, and dominates, only to be swept away by forces beyond its control. What comes afterward is always different, sometimes unimaginably so. A world after a mass extinction is never the same as the one before. Species that once seemed permanent vanish forever, while survivors exploit empty niches, evolving into entirely new forms. Resets are painful on the scale of life, but they are also creative. They open space for new possibilities, for life to try again in different directions. The concept of mass extinctions also forces us to think about resilience and fragility. On the one hand, Earth itself is resilient, continuing to support life, even after devastation. On the other hand, individual species, even entire groups of organisms, are fragile. They can vanish in the blink of a geological eye. For humans, this duality is sobering. We belong to a species that has flourished in a short period of time, reshaping the planet in ways no other species has. But if resets are part of Earth's story, then we must recognize that we too could one day be swept away, replaced by something entirely new. Extinction is the rule, the exception in deep time. Over 99% of all species that have ever lived are gone. Their stories ended by natural resets. To imagine that we are immune to the same fate would be a mistake. What makes the study of mass extinctions even more compelling is the possibility that we are living on the edge of another one. Many scientists warn that human activity, deforestation, pollution, climate change, habitat destruction, overfishing, and the spread of invasive species is driving the 6th great extinction. Unlike the others, this one is not caused by volcanoes or asteroids, but by the actions of a single species. Species are disappearing at rates far above natural background levels, and ecosystems are showing signs of collapse. Amphibians, insects, birds, and mammals are all affected. If this continues, the 21st century may be remembered as another reset, one of our own making. Whether humanity itself would survive such a reset is an open question. But the pattern of Earth's history suggests that life as a whole would endure, even if our role within it vanished in the quiet of reflection. Mass extinctions remind us that endings are also beginnings. The Ordovician extinction opened the way for new marine life, the Devonian for forests, the Permian for dinosaurs, the Triassic for their dominance, and the Cretaceous for mammals and eventually humans. Each reset erased worlds, but each reset also seeded the possibility of something different, something new. That is the paradox of planetary resets. They destroy, but they also create. They close one chapter, but open another in Earth's long and unfinished story. Imagine Earth as a world that has already been reset. One must look no further than the cycles of ice ages and climate shifts that have shaped the landscapes, ecosystems, and even the destiny of humankind. Unlike sudden cataclysmic events such as asteroid impacts or massive volcanic eruptions, ice ages unfold slowly, over tens of thousands or even millions of years, yet their power to reset the planet is undeniable. These immense swings in climate alter coastlines, redraw habitats, force migrations, and rewrite the evolutionary script. The frozen chapters of Earth's past are reminders that the planet we see today is only a temporary arrangement, one molded by glaciers, melted by warmth, and forever transformed by the breath of shifting climates for the past 2.6 million years. Earth has been in what scientists call the Quaternary glaciation, a period defined by repeated cycles of advancing and retreating ice sheets. Within this larger epoch, the planet has swung between glacial periods, when ice sheets expanded to cover vast portions of North America, Europe, and Asia, and interglacial periods, like the one we live in today, where the ice recedes, climates moderate, and ecosystems flourish. These cycles are driven by a combination of factors, including subtle variations in Earth's orbit and tilt, what are known as Milankovitch cycles, which alter the distribution of sunlight on the planet's surface. Over time, these orbital rhythms, combined with feedbacks involving greenhouse gases and ocean circulation, create the dramatic pulses of ice and warmth that mark Earth's climate history. During the height of the last glacial maximum, around 20,000 years ago, enormous ice sheets stretched across much of the northern hemisphere. In North America, the Laurentide ice sheet covered Canada and extended into the northern United States, burying regions beneath miles of ice. Cities like Chicago, New York, and Seattle would have been uninhabitable under the crushing weight of glaciers. Sea levels during this time were more than 300 feet lower than they are today, exposing vast land bridges that connected continents. One of the most famous of these was Beringia, the land bridge between Siberia and Alaska, which allowed early humans and animals to migrate into the Americas. The very presence of people across North and South America is a direct result of these icy resets. As glacial conditions forced our ancestors to move, adapt, and find new homes, the ice retreated and the climate warmed. The world reset again. Meltwater from the collapsing ice sheets flooded into the oceans, raising sea levels and drowning the land bridges that had once enabled migrations. Coastlines were redrawn. Vast regions of tundra and steppe gave way to forests and grasslands. The great megafauna of the Ice Age, mammoths, saber-toothed cats, giant ground sloths, struggled to adapt to the changing environment and the pressures of human hunting. Many of them vanished forever, victims of a reset that opened ecological space for smaller, more adaptable species. For humanity, the retreat of the ice created fertile river valleys and temperate climates that allowed agriculture to emerge, setting the stage for the rise of civilizations. Without the end of the last ice age, the course of human history would have been radically different. The influence of ice ages reaches far beyond the shaping of human migration and culture. They sculpted the very land itself. Glaciers carved out the Great Lakes of North America, scooped valleys in the Alps, and left behind the rolling hills and fertile soils of regions like the American Midwest. They deposited moraines, drumlins, and other features that define landscapes to this day. In many parts of the United States, from New England to the Pacific Northwest, the beauty of mountains, rivers, and plains is the legacy of ancient ice. These landforms are geological fingerprints of planetary resets, silent reminders that entire continents were once ground beneath sheets of moving ice. The impact of ice ages on climate was equally profound. Global temperatures plummeted during glacial periods, only to rebound during interglacials. These fluctuations influenced not only where plants and animals could live, but also how they evolved. Species that survived did so by adapting to extreme conditions: thick fur, fat reserves, migratory patterns, while others perished. Even in the oceans, ice ages reshaped life. As glaciers locked away vast amounts of water, sea levels dropped, altering currents and marine habitats. Coral reefs vanished and reappeared. Fish populations shifted and ecosystems restructured. In every sense, ice ages pressed the reset button on life, forcing adaptations and innovations across the tree of evolution for humans. Climate shifts brought both challenges and opportunities. Archaeological evidence suggests that glacial advances often pressured human populations into smaller, habitable refuges, where they developed new tools, strategies, and cultures. The harsh cold drove innovation, as people learned to create clothing, shelter, and methods for storing food. Some anthropologists argue that the unpredictability of these climatic swings may have fostered the intelligence, creativity, and resilience that define our species today. In other words, the resets of ice ages were not only environmental events, but also engines of human evolution, shaping who we are and how we live. The forgotten drama of ancient climate shifts also extends to episodes like the Younger Dryas, a sudden cooling period about 12,800 years ago. After the last ice age began to wane, temperatures abruptly dropped back to near glacial conditions for over 1,000 years before warming resumed. The causes remain debated: perhaps the disruption of ocean circulation by meltwater, perhaps the impact of a comet. Regardless of the trigger, the Younger Dryas was a climatic reset that profoundly affected early human societies. In the Middle East, where some of the earliest agriculture was beginning, shifting climates forced people to adapt quickly, and some researchers believe this stress accelerated the domestication of plants and animals. Once again, a climate reset became a turning point for humanity's path toward civilization. Beyond the Quaternary period, Earth's history reveals even more extreme examples of climate resets. Around 700 million years ago, during the Cryogenian period, the planet may have entered a snowball Earth state, when ice covered nearly the entire globe. Imagine oceans frozen to the equator, continents buried beneath thick sheets of ice, and life struggling to survive in tiny refuges of liquid water near volcanic vents or under the ice. For tens of millions of years, Earth remained locked in this frozen world. When the ice finally melted, greenhouse gases accumulated in the atmosphere, and the planet swung back to warmth. This dramatic reset paved the way for the emergence of complex multicellular life, setting the stage for the evolutionary explosion of the Cambrian period. Without the severity of snowball Earth, the trajectory of life might have been entirely different. Climate shifts have also created lush greenhouse worlds, opposite to the frozen epochs. During the Cretaceous period, when dinosaurs roamed, Earth was much warmer than today. Tropical conditions extended to the poles, and sea levels were hundreds of feet higher. Crocodiles lived in what is now the Arctic, and forests spread where today there is tundra. These warm periods, too, were resets, creating radically different ecosystems than the ones that came before or after. Ice ages and warm ages represent the extremes of Earth's climate system, and each time the pendulum swings, life must adapt, evolve, or perish when viewed through the lens of deep time. These cycles of ice and warmth remind us that climate is not static, but dynamic, capable of reshaping the Earth again and again. They also remind us that resets need not be sudden to be transformative. Over the span of millennia, glaciers can grind mountains into dust, seas can rise to drown continents, and forests can migrate thousands of miles. For species, including our own, these shifts are as powerful as any asteroid strike, because they redefine the very conditions of survival. What feels like stability to us, living in centuries, is in reality only a brief pause in the restless dance of Earth's climate in the United States. Evidence of these climate resets is visible all around. The Great Plains exist in part because of glacial deposits. The Hudson River Valley was carved by advancing ice. The fertile soils of the Midwest, which sustain agriculture to this day, are the legacy of glaciers grinding rock into fine dust. Even the cultural heritage of Native American peoples, their migrations and adaptations, was influenced by the glacial and post-glacial worlds they inhabited. Every field, every river, every mountain tells the story of resets written in ice and climate. To reflect on ice ages and climate shifts is to acknowledge that Earth has been reset not just by catastrophes, but by cycles as steady and patient as the ticking of a cosmic clock. Ice advances, ice retreats, climates swing, and each time life changes. Species disappear, new ones arise, and landscapes are rewritten. Humanity itself is a product of these cycles, our existence intertwined with the rhythm of ice and warmth, proof that planetary resets can shape not only the physical world, but also the destiny of civilizations. To imagine Earth as a world that has already been reset, one must look no further than the cycles of ice ages and climate shifts that have shaped the landscapes, ecosystems, and even the destiny of humankind. Unlike sudden cataclysmic events such as asteroid impacts or massive volcanic eruptions, ice ages unfold slowly, over tens of thousands or even millions of years, yet their power to reset the planet is undeniable. These immense swings in climate alter coastlines, redraw habitats, force migrations, and rewrite the evolutionary script. The frozen chapters of Earth's past are reminders that the planet we see today is only a temporary arrangement, one molded by glaciers, melted by warmth, and forever transformed by the breath of shifting climates. For the past 2.6 million years, Earth has been in what scientists call the quaternary glaciation, a period defined by repeated cycles of advancing and retreating ice sheets. Within this larger epoch, the planet has swung between glacial periods, when ice sheets expanded to cover vast portions of North America, Europe, and Asia, and interglacial periods, like the one we live in today, where the ice recedes, climates moderate, and ecosystems flourish. These cycles are driven by a combination of factors, including subtle variations in Earth's orbit and tilt, what are known as Milankovitch cycles, which alter the distribution of sunlight on the planet's surface. Over time, these orbital rhythms, combined with feedbacks involving greenhouse gases and ocean circulation, create the dramatic pulses of ice and warmth that mark Earth's climate history. During the height of the last glacial maximum, around 20,000 years ago, enormous ice sheets stretched across much of the northern hemisphere. In North America, the Laurentide ice sheet covered Canada and extended into the northern United States, burying regions beneath miles of ice. Cities like Chicago, New York, and Seattle would have been uninhabitable under the crushing weight of glaciers. Sea levels during this time were more than 300 feet lower than they are today, exposing vast land bridges that connected continents. One of the most famous of these was Beringia, the land bridge between Siberia and Alaska, which allowed early humans and animals to migrate into the Americas. The very presence of people across North and South America is a direct result of these icy resets. As glacial conditions forced our ancestors to move, adapt, and find new homes as the ice retreated and the climate warmed, the world reset again. Meltwater from the collapsing ice sheets flooded into the oceans, raising sea levels and drowning the land bridges that had once enabled migrations. Coastlines were redrawn. Vast regions of tundra and steppe gave way to forests and grasslands. The great megafauna of the Ice Age, mammoths, saber-toothed cats, giant ground sloths, struggled to adapt to the changing environment and the pressures of human hunting. Many of them vanished forever, victims of a reset that opened ecological space for smaller, more adaptable species. For humanity, The retreat of the ice created fertile river valleys and temperate climates that allowed agriculture to emerge, setting the stage for the rise of civilizations. Without the end of the last ice age, the course of human history would have been radically different, yet the influence of ice ages reaches far beyond the shaping of human migration and culture. They sculpted the very land itself. Glaciers carved out the Great Lakes of North America, scooped valleys in the Alps, and left behind the rolling hills and fertile soils of regions like the American Midwest. They deposited moraines, drumlins, and other features that define landscapes to this day. In many parts of the United States, from New England to the Pacific Northwest, the beauty of mountains, rivers, and plains is the legacy of ancient ice. These landforms are geological fingerprints of planetary resets, silent reminders that entire continents were once ground beneath sheets of moving ice. The impact of ice ages on climate was equally profound. Global temperatures plummeted during glacial periods, only to rebound during interglacials. These fluctuations influenced not only where plants and animals could live, but also how they evolved. Species that survived did so by adapting to extreme conditions: thick fur, fat reserves, migratory patterns, while others perished. Even in the oceans, ice ages reshaped life. As glaciers locked away vast amounts of water, sea levels dropped, altering currents and marine habitats. Coral reefs vanished and reappeared. Fish populations shifted and ecosystems restructured. In every sense, ice ages pressed the reset button on life, forcing adaptations and innovations across the tree of evolution for humans. Climate shifts brought both challenges and opportunities. Archaeological evidence suggests that glacial advances often pressured human populations into smaller, habitable refuges, where they developed new tools, strategies, and cultures. The harsh cold drove innovation, as people learned to create clothing, shelter, and methods for storing food. Some anthropologists argue that the unpredictability of these climatic swings may have fostered the intelligence, creativity, and resilience that define our species today. In other words, the resets of ice ages were not only environmental events, but also engines of human evolution, shaping who we are and how we live. The forgotten drama of ancient climate shifts also extends to episodes like the Younger Dryas, a sudden cooling period about 12,800 years ago. After the last ice age began to wane, temperatures abruptly dropped back to near glacial conditions for over 1,000 years before warming resumed. The causes remain debated: perhaps the disruption of ocean circulation by meltwater, perhaps the impact of a comet. Regardless of the trigger, the Younger Dryas was a climatic reset that profoundly affected early human societies. In the Middle East, where some of the earliest agriculture was beginning, shifting climates forced people to adapt quickly, and some researchers believe this stress accelerated the domestication of plants and animals. Once again, a climate reset became a turning point for humanity's path toward civilization. Beyond the Quaternary period, Earth's history reveals even more extreme examples of climate resets. Around 700 million years ago, during the Cryogenian period, the planet may have entered a snowball Earth state, when ice covered nearly the entire globe. Imagine oceans frozen to the equator, continents buried beneath thick sheets of ice, and life struggling to survive in tiny refuges of liquid water near volcanic vents or under the ice. For tens of millions of years, Earth remained locked in this frozen world. When the ice finally melted, greenhouse gases accumulated in the atmosphere, and the planet swung back to warmth. This dramatic reset paved the way for the emergence of complex multicellular life, setting the stage for the evolutionary explosion of the Cambrian period. Without the severity of snowball Earth, the trajectory of life might have been entirely different. Climate shifts have also created lush greenhouse worlds, opposite to the frozen epochs. During the Cretaceous period, when dinosaurs roamed, Earth was much warmer than today. Tropical conditions extended to the poles, and sea levels were hundreds of feet higher. Crocodiles lived in what is now the Arctic, and forests spread where today there is tundra. These warm periods, too, were resets, creating radically different ecosystems than the ones that came before or after. Ice ages and warm ages represent the extremes of Earth's climate system, and each time the pendulum swings, life must adapt, evolve, or perish when viewed through the lens of deep time. These cycles of ice and warmth remind us that climate is not static, but dynamic, capable of reshaping the Earth again and again. They also remind us that resets need not be sudden to be transformative. Over the span of millennia, glaciers can grind mountains into dust, seas can rise to drown continents, and forests can migrate thousands of miles. For species, including our own, these shifts are as powerful as any asteroid strike, because they redefine the very conditions of survival. What feels like stability to us, living in centuries, is in reality only a brief pause in the restless dance of Earth's climate in the United States. Evidence of these climate resets is visible all around. The Great Plains exist in part because of glacial deposits. The Hudson River Valley was carved by advancing ice. The fertile soils of the Midwest, which sustain agriculture to this day, are the legacy of glaciers grinding rock into fine dust. Even the cultural heritage of Native American peoples, their migrations and adaptations, was influenced by the glacial and post-glacial worlds they inhabited. Every field, every river, every mountain tells the story of resets written in ice and climate. To reflect on ice ages and climate shifts is to acknowledge that Earth has been reset not just by catastrophes, but by cycles as steady and patient as the ticking of a cosmic clock. Ice advances, ice retreats, climates swing, and each time life changes. Species disappear, new ones arise, and landscapes are rewritten. Humanity itself is a product of these cycles, our existence intertwined with the rhythm of ice and warmth, proof that planetary resets can shape not only the physical world, but also the destiny of civilizations. When we think about history, we imagine libraries, archives, and digital records holding the memory of human events. Yet Earth itself is the oldest storyteller, carrying within its rocks, sediments, and fossil layers the chronicles of deep time. But unlike a careful historian, it does not preserve everything. It is not a library where every book is stored neatly, waiting to be read. It is more like a manuscript constantly being rewritten, pages torn out, lines smudged, and entire chapters erased. This phenomenon, the way Earth remembers and forgets, is what scientists call geological memory and erasure. To understand what it means to ask whether Earth has already been reset, one must first grasp that the very surface beneath our feet is both a record and a destroyer of its own past. The story of Earth is a fragile one, incomplete, full of missing pages, and shaped as much by what has been lost as by what remains. Consider the fact that Earth is about 4.5 billion years old, yet the oldest rocks we have discovered are a little over 4 billion years old, and even those are fragmentary. The vast majority of Earth's early history has been erased, recycled back into the planet through the processes of plate tectonics and erosion. Continents drift, collide, and tear apart. Mountains rise, only to be worn down by wind and rain. Ocean floors spread apart at mid-ocean ridges and are eventually consumed in subduction zones, dragged back into the mantle and melted. This recycling process means that Earth, unlike the Moon or Mars, does not keep a complete record of its surface. The craters and scars that might have told us of ancient impacts, volcanic eruptions, or even evidence of early life have mostly vanished. The Earth we see today is not the same Earth of billions of years ago. It is a world that has already been reset, not once, but countless times. One of the clearest examples of geological erasure comes from the fate of the supercontinents. Throughout Earth's history, landmasses have repeatedly come together and broken apart in cycles lasting hundreds of millions of years. Pangaea, the most famous of these supercontinents, existed about 300 million years ago, uniting almost all of Earth's land in one massive expanse. But Pangaea itself was not the first. Before it, there were others: Rodinia, Columbia, Nuna, and even earlier formations, each representing a chapter in Earth's grand tectonic saga. Yet when we look for evidence of these ancient supercontinents, much of it has been erased. The rocks that once formed their mountains have eroded into sediments, scattered by rivers and seas. The ocean floors that bordered them have long been recycled into the mantle. We reconstruct their existence not from intact records, but from fragments, magnetic alignments frozen in rocks, rare mineral deposits, or faint patterns of ancient mountain belts. These fragments are like torn scraps of parchment, forcing geologists to piece together entire worlds from the smallest surviving clue. Fossils, too, tell the story of geological memory and erasure. For every species we know from the fossil record, there are countless others that left no trace at all. Fossilization is a rare process, requiring just the right conditions of burial, mineralization, and preservation. Entire lineages may have flourished and disappeared without leaving a single fossil to mark their existence. Even when fossils form, they are vulnerable to destruction, eroded by wind, dissolved by water, or metamorphosed by heat and pressure deep within the earth. What we have today is a partial archive, biased toward hard-shelled creatures that live near water, or those that happen to be buried quickly. Soft-bodied animals, plants, and microbes, which may have played enormous roles in ancient ecosystems, are often missing from the record. When we look at the fossil record, we are not seeing the full picture of life's past. We are seeing a story that has been edited and censored by geological processes. A story of memory riddled with gaps. Some of Earth's most profound mysteries stem directly from this erasure. For instance, we know that life originated more than 3.5 billion years ago, but the details of how and where remain hidden. Early rocks that might have preserved the chemical signatures of life have been altered, melted, or destroyed. We search for clues in ancient zircons, tiny crystals that can survive geological upheavals, but even these carry only partial whispers of the conditions in which they formed. The earliest pages of Earth's biological history have been wiped clean, leaving scientists to speculate whether life began in deep-sea hydrothermal vents, shallow ponds, or other environments entirely. Similarly, theories about past civilizations, if any existed before our own recorded history, are haunted by the reality of geological erasure. Cities, technologies, or monuments built tens of thousands of years ago would likely have been ground down by glaciers, buried under sediment, or lost beneath shifting coastlines, leaving virtually no trace for future archaeologists. An striking example of geological erasure lies in the mystery of impact craters. Throughout its history, Earth has been bombarded by asteroids and comets, just like the Moon. Yet while the Moon's surface is scarred with craters from billions of years ago, Earth retains relatively few visible craters. Why? Because erosion, tectonics, and sedimentation have erased them. Large impacts may have reshaped Earth's climate, triggered extinctions, or even influenced the course of evolution. But the scars of these events have been softened or obliterated by the planet's restless surface. The Chicxulub crater in Mexico, associated with the extinction of the dinosaurs, is one of the rare examples preserved well enough to be studied. Without it, we might never have connected the dots between a cosmic impact and the end of the age of reptiles. How many other catastrophic events have left no visible trace? The lack of evidence does not mean they did not occur. It means Earth itself has hidden them away, like secrets buried in its shifting crust. Volcanoes, too, contribute to the rewriting of Earth's memory. When supervolcanoes erupt, they can blanket continents with ash, altering climates and ecosystems. Over time, however, rain, wind, and plate movements scatter and bury these deposits. Ancient eruptions leave behind only thin chemical signatures in rocks or subtle anomalies in mineral composition. For instance, the massive eruptions of the Deccan Traps in India and the Siberian Traps in Russia are linked to mass extinctions. Yet much of the evidence of their full extent has been altered or destroyed by geological processes. Earth does not preserve these events in pristine detail, it overwrites them, forcing scientists to read between the lines of altered stone. Even human history is not immune to geological erasure. Rising seas have swallowed coastal settlements, earthquakes have destroyed cities, and shifting rivers have buried cultures beneath layers of silt. Archaeologists working today know that what they uncover is only a fraction of what once existed. Imagine how much will remain after tens of thousands of years, or even millions. Stone monuments may endure for a time, but most of human civilization, its buildings, roads, and artifacts will be erased by the same forces that erased the mountains and continents of earlier ages. Future beings, if they exist, may find only traces of us, scattered fragments that tell an incomplete and distorted story. Just as we reconstruct the lives of dinosaurs or trilobites from incomplete fossils, so, too, might our species one day be a shadowy presence in the deep archive of Earth's imperfect memory. This duality of memory and erasure is not merely a limitation. It is also a reminder of Earth's resilience and dynamism. The planet is not static. It is alive with processes that build, destroy, and renew. From the perspective of deep time, erasure is itself a form of reset. Each time a mountain is worn down or a continent is reassembled, the planet begins again, layering new stories atop the old. In this way, the Earth does not keep a perfect record of its history, but rather creates a living document, one that evolves along with the world itself. The absence of complete records challenges us to be humble, to recognize that what we know of Earth's past is always provisional, always partial, and always vulnerable to revision as new fragments come to light. To say that Earth has already been reset is to acknowledge this interplay of geological memory and erasure. The story of our world is one of cycles written on shifting pages, of lives and landscapes erased by fire, water, and time, only to be replaced by new chapters. The Earth we walk upon today is not only the product of its surviving memories, but also of all that has been lost to its restless, ever-changing nature. When we look at Earth through the lens of deep time, it becomes clear that resets are not rare anomalies, but part of the planet's natural rhythm. The question, then, is not whether Earth will reset again, but when and how. The history of life and climate reveals that resets come in many forms, sometimes sudden, sometimes gradual, sometimes triggered by forces beyond our control, and sometimes by our own actions. The idea of the next reset invites us to imagine the possible futures of our world, futures that could be shaped by cosmic events, environmental changes, or the choices humanity makes in the coming centuries. Just as the ice ages and mass extinctions shaped what Earth has become, the next reset may already be unfolding around us. Own possibility lies in the forces of climate change, which today are no longer distant geological curiosities, but pressing realities of our own era. Over the past century, human activity has altered the composition of Earth's atmosphere in measurable and profound ways. By burning fossil fuels, cutting down forests, and releasing greenhouse gases, we have amplified the natural greenhouse effect, leading to warming temperatures, melting ice sheets, rising seas, and shifting weather patterns. Scientists warn that if this trend continues, it could create conditions unlike anything humanity has ever known. A warmer world may resemble greenhouse climates of the distant past, when tropical forests spread toward the poles and sea levels rose high enough to submerge vast swaths of land. Such a reset would not be instantaneous, but its consequences would ripple through ecosystems, economies, and civilizations, reshaping the course of history in ways just as profound as the glacial cycles of the past. Another possible reset could come from the Earth itself, through massive volcanic events. The planet has seen episodes when enormous volcanic outpourings reshaped its climate and triggered mass extinctions. The Siberian Traps eruption about 252 million years ago, for example, released so much carbon dioxide and methane that it caused runaway global warming and led to the Permian extinction, the most severe loss of life in Earth's history. Though rare, such events are part of Earth's long-term cycles, and it is conceivable that another supervolcanic eruption could occur in the distant future. Even on shorter timescales, known supervolcanoes like Yellowstone in the United States or Toba in Indonesia hold the potential to unleash enough ash and gas to disrupt agriculture, block sunlight, and trigger a temporary but devastating volcanic winter. If such an event happened in our lifetimes, it would challenge human resilience and test the foundations of our interconnected global society and the Earth itself. Cosmic forces also loom as agents of potential resets. The asteroid that struck the Yucatan Peninsula 66 million years ago reset the planet's evolutionary trajectory, ending the reign of dinosaurs and paving the way for mammals to thrive. Today, astronomers monitor the skies for near-Earth objects that could pose a similar threat. While catastrophic impacts are rare, they are not impossible. Even smaller impacts could devastate regional ecosystems or trigger global climatic disruptions. Humanity has begun to develop technologies to detect and potentially deflect such threats, but the universe remains unpredictable. A reset from the cosmos could arrive with little warning, reminding us that Earth is not isolated but part of a wider and sometimes perilous celestial neighborhood. A third dimension of the next reset may be technological and self-inflicted. Humanity wields powers today that rival the forces of nature. Nuclear weapons, for instance, carry the potential to devastate not only individual nations, but entire civilizations. The concept of a nuclear winter, in which widespread detonations throw massive amounts of soot into the atmosphere, blocking sunlight and disrupting agriculture, reflects how human decisions could trigger conditions resembling the aftermath of volcanic eruptions or asteroid impacts. Similarly, advanced technologies such as artificial intelligence, genetic engineering, or geoengineering, while offering solutions and opportunities, also carry risks that could spiral beyond our control. The very ingenuity that allowed humans to survive past resets could one day become the trigger of a new epidemics too. Remind us of how fragile human systems can be. While diseases may not reset the planet's ecosystems in the same way as ice ages or asteroid impacts, they have the power to reset societies, economies, and cultures. Historical events like the Black Death reshaped the trajectory of nations, and modern pandemics reveal how quickly global networks can falter. In the context of resets, pandemics underscore that vulnerability is not always planetary in scale, can also be deeply human, affecting how civilizations rise, adapt, or fall. The resilience of human societies in the face of such challenges determines whether they become temporary disruptions or enduring resets. Looking further ahead, we must also consider the possibility of resets on astronomical timescales. The Sun, which sustains all life on Earth, is not eternal. In about 5 billion years, it will expand into a red giant, potentially engulfing the inner planets and rendering Earth uninhabitable. Long before that, gradual changes in solar output may alter Earth's climate enough to trigger new conditions for life. While these timescales are almost unimaginably long compared to human history, they remind us that planetary resets are not just a matter of centuries or millennia, but of cosmic inevitability. Earth, like all worlds, is temporary, and its resets are woven into the fabric of stellar evolution itself for people living today. However, the most pressing question is how humanity responds to the possibility of a near-term reset. Unlike the dinosaurs, we possess awareness of our vulnerabilities and some capacity to mitigate them. We can reduce greenhouse gas emissions to lessen the impact of climate change. We can develop planetary defense strategies against asteroids. We can monitor volcanic activity, invest in resilient infrastructure, and create systems to prepare for global crises. The choices made in the coming decades will shape whether the next reset is catastrophic or whether it can be softened into a transformation that life can endure and adapt to. The very fact that we are aware of resets and capable of anticipating them gives humanity an unprecedented role in shaping Earth's future cycles. At the same time, the idea of the next reset can inspire a sense of humility. Resets remind us that Earth is not permanent, that civilizations are fragile, and that our species is part of a much larger story. They reveal that no matter how advanced we become, we remain vulnerable to the same forces that reshaped continents, extinguished species, and rewrote the course of evolution. The awareness of future resets is not only a warning, but also an invitation to live with a deeper appreciation of the present, recognizing the rarity and beauty of the interglacial, relatively stable world we inhabit. Just as ice ages once sculpted the landscapes we call home, and ancient catastrophes once made space for mammals to thrive. The next reset will shape whatever comes after you, seen from the perspective of deep time. Humanity may itself be only a brief chapter in Earth's long narrative. Civilizations rise and fall, species come and go, and the planet resets, not out of malice or design, but as part of its nature. If Earth has been reset many times in the past, then it is almost certain it will be reset again in the future. The open question is how that reset will unfold, and whether we will be active participants in shaping its outcome or passive witnesses to forces beyond our control. When we ask the question, what if Earth has already been reset? We are really asking ourselves to see our planet not as a static stage for human history, but as a living, breathing participant in the cosmic story. From the cycles of mass extinctions that swept away entire lineages, to the slow advance and retreat of glaciers that reshaped continents, to the erasure of ancient histories by the restless churn of geology, Earth has never been fixed. It has been transformed again and again, each reset, carving away what was and opening the door for what could be. The planet has endured fire and ice, flood and impact, collapse and renewal. And through it all, life has found ways to survive, adapt, and even flourish. To understand this is to recognize both the fragility and resilience of our world. Fragile because civilizations, species, and even landscapes can vanish in the blink of geological time. Resilient because the Earth itself endures, carrying life forward in new and unexpected forms. The very air we breathe, the mountains we climb, the oceans that cradle us, all are products of past resets, shaped by forces far older than humanity. We are, in a sense, children of catastrophe, beneficiaries of cycles that cleared the way for our existence, and as we look toward the future, the possibility of the next reset is not a tale of doom, but a reminder of continuity. Whether through climate change, cosmic impact, volcanic eruption, or the slow transformations of deep time, Earth will continue to evolve. The question is not whether the planet will change, but how we, as a species, will respond. Will we adapt and endure, as life always has, or will we become another chapter erased by time? In either case, the cycles will go on, weaving destruction and renewal into the fabric of existence. There is comfort in this perspective. It reminds us that we are part of something vast, something that stretches beyond our fears, beyond our lifetimes, beyond even the history of our species. Earth has already been reset, and yet here we are, alive in this moment, breathing, thinking, and reflecting on the mystery of it all. To live with that awareness is to see not only the impermanence of our world, but also its profound beauty, the beauty of a planet that has endured countless endings, only to begin again.